Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
Hello and welcome. I'm Alison Stewart. I am the host of Cut the Crop. And today we're talking about making peas pay. And our guest is Adrian Russell from Plant Research Limited. Welcome, Adrian.
Thanks, Alison.
Yeah. So let's just start off with me asking the question, what sort of things should growers be thinking about when deciding which paddock to put into peas?
Well, I think the first thing they should think about is their paddock selection, because that's quite critical to setting up a good crop. So they need to think about their fertility and do fertility checks to see what the status of all the nutrients are and do the corrections if they need to. pH is quite important. They want to aim for a pH of between 5.9 and 6.4. Anything less than that and they could have yield problems and disease issues coming into their crop. Peas generally follow grass quite well in a rotation, and they also break disease cycles, so they're useful for that. But getting that paddock selection right is pretty important. They aim for a free draining soil, not too heavy. Peas don't like waterlogging. So something that's free draining. If they're growing a dryland crop, not too light, because they're going to run out of moisture later in the season and that'll limit their yield. But yeah, those are the key things probably.
So rotation-wise, peas fit in really nicely into rotations down in Canterbury?
Yeah, they're really useful in a rotation because they fix nitrogen and they have quite a deep rooting system. They can improve soil structure, particularly for cereal rotations. They're a really good break crop option, particularly if you've got take-all issues. They'll break that disease cycle for the take-all. So really good option.
So is there a particular planting period that's optimum for peas?
Yeah, Derek Wilson and Peter Jamieson, who worked for DSIR many years ago, did a lot of crop modelling back in the 80s and 90s, and they came up with the date of September the 26th as the day that you aim for. And, and that fits their mathematical models for getting the optimum amount of radiation that's being intercepted by the crop. If you get enough radiation, that converts to yield, and that's the date. Beyond that date, every week that you go beyond that date, you're losing significant amounts of yield. By the time you get into November, you're really impacting on yield. In some cases, if you're growing a processed pea crop, you haven't really got a choice when you're growing it, because you've got to fit into the calendar of the processing factory. But it's just something to keep in mind, that if you're signing a contract at a certain price and somebody wants you to plant in November, you can't expect to have an optimum yield at that time of the year.
So what would be the sort of optimum yields that you could expect down here, say, versus up in the North Island?
For Canterbury, the yields have been increasing over the years, and it depends on what type of pea you're growing. If you're growing a seed crop of say, yellow peas now, then 6 tonnes is pretty much expected these days. And on occasion we get a couple of 7-tonne crops a year now. Yeah. Probably averaging about 5.5 tonnes. If you're growing a Marifat crop, they're getting up to 5 tonnes per hectare on average, some doing 6. If you're doing some processed pea seed crops that are imported varieties for seed production, it's a little bit unclear what you might get, but they're generally a bit lower. So if you're signing up for a garden pea processed seed crop, you probably want a little bit more money per tonne, because you're going to get a lower yield generally.
Yeah. So other than like making sure that you get it planted at the right time, what are the other major constraints to yield that the grower is going to experience?
You've got constraints like disease, and disease can have a big impact, and Aphanomyces is one of the big ones for the processed growers, particularly if they're within a radius of a processing factory. If they're within an hour radius, which is the area that the processed pea factories like to contract their crops, they've had a history of pea cropping over a long time, so their disease levels in the soil might be higher. So you can set up an Aphanomyces soil test about this time of the year. It takes about 5 to 6 weeks to get a result back from that. That won't just tell you the Aphanomyces load, it'll also identify other things like fusariums, pythiums, rhizoctonia, and the other important thing it can pick up is residual chemicals that might have been there from the previous crop that the farmer might not be aware of, but that can have a seriously big impact on the next crop.
And so how accurate are these soil tests from the point of view, I mean, and I've worked in this area
right.
in my previous life,
Yep.
You get a certain value given of Aphanomyces or whatever. What does it translate to though for the grower? I mean, are they accurate enough such that the grower can make, accurate decisions about whether to plant there or not? Because so much of it is driven by the environmental conditions as well as the inoculant.
Yeah, absolutely. And I think we always tell the farmers that it's a guide more than anything. It tells you if everything's present for that fungal pathogen to grow and thrive, this is the worst case scenario of what could happen.
Yeah.
Because that soil is managed with temperature and light and moisture for optimum conditions for the pathogen. But they might grow a pea in a high disease paddock and get away with it because the conditions that year aren't conducive for that pathogen to thrive. But it's just a guide to say it's a risk factor. So we can say a DSI of over 75 from a scale of 0 to 100 is high risk. So if the conditions are really conducive for that pathogen in that year, you could have a problem, but you might get away with it.
Yeah, that's right.
That's
and
the
it's
risk to take.
Are you prepared to take the risk?
Yeah.
So, I mean, crop rotation has always been, the big way to manage these soil-borne problems. Is that still the mainstay, or have we got some new cultivars coming through with a bit of resistance, or are there any new chemicals, seed treatments that might work?
For Aphanomyces, there really isn't much in the way of resistance. There's a little bit of tolerance, but still not. There's not much in the genetics, and we're hoping some of the newer technologies, if we're allowed to use them at some stage, might give us some solutions to that.
You don't hold your breath, Adrian,
No,
I'm afraid.
No, I've been holding it for a long time. But we really need those technologies and for the New Zealand government to consider those technologies to make a difference in that area. Other diseases, we do have some chemicals that are good chemicals, like ascochyta blight, which can be seed transmitted. We have some very good chemicals as a seed treatment or as a foliar spray, but the farmers need to get those sprays generally on quite early in the life cycle so that they can get good coverage and good activity within the plant, even down to 6 node stage. And in the Making Peas Pay book, which FAR published, there's some good information about early application of foliar fungicides to control ascochyta.
Yeah.
Downy mildew, you've less options. Phosphoric acid can control it to some extent, but we haven't got much in the way of chemicals for downy mildew. Powdery mildew is very easy to control, but again, you've got to get onto it really, really quickly. If you plant a crop in September, you'll see that disease come in about the 3rd week of December. It's like clockwork. It's always there about then. So if you get in and control it then, you'll get good control. If you leave it until after Christmas, you're trying to put out a bushfire and you'll never get on top of it.
So are any of these chemical groups showing resistance problems?
There seems to be some resistance issues coming in with powdery mildew, but powdery mildew is not one that we get every year. It's not that common in New Zealand as in other countries. But yes, definitely you've got to manage your chemicals and look after them, because we need the chemicals to work with the resistance that are being developed within the varieties. We can't do without both of those working together.
So are there any chemical groups that are at risk of being lost, as in not going to be registered anymore, in the sense like the neonics or whatever?
Yeah, I think definitely there's pressure on globally and the markets that we're working with our genetics. There are already some countries where those chemicals are not being used anymore, and that pressure will continue. And currently in the UK and France, they're having serious virus problems because they can't use the chemicals anymore. So they're saying we need resistance and variety resistance.
And so what I mean, are you involved in a major pea breeding program at the moment?
Yes. Yeah. We've got a program that's got a global reach, and we're working in 10 countries globally. We have about 70% of the Pacific Northwest market in the US with our genetics.
Okay, and what kind of attributes are you breeding for?
At the moment, it's all about virus resistance, and particularly P-Nation mosaic, which we don't have in New Zealand, and we don't really want it because it's a nasty one, but we have good resistance to that. So because the chemicals are being withdrawn from the market, then they're screaming out for resistance in the varieties.
So are these cultivars going to be available in New Zealand as well?
Yes, some of them are already grown, even though we don't have the virus. But I guess it's a protection and a backup strategy. If that virus is ever introduced, some of the varieties will already have resistance to them.
So what about the the thinking of climate change? Are you looking at developing drought tolerant cultivars and things like that?
Yeah, we are. We're doing some of that ourselves. University of Canterbury are helping us with that with a PhD funded project to look at in vitro breeding. So we're looking for variation within atricellus or tissue culture approach where there are mistakes in the DNA coding, and we're looking to put those cells under stress and find those mistakes, which might allow it to be more drought tolerant or cold tolerant, because we're following particular pathways and looking for particular changes to those pathways that might mean they have that tolerance.
Yeah.
And we're also working with some projects in Belgium in that space as well, which is really interesting.
So I'm just going to go completely off script here because I'm really interested, how come you're sitting here being sort of a world leading pea breeder? How did that happen?
I really don't know, Alison. I think the Americans in particular find it quite amusing that the varieties that they're growing generally are from New Zealand. And I guess we got lucky in a way because we bred the first variety that didn't fall over in the US, and the peas that fall over, the farmers have to travel really slow. They get a lot of dirt in the sample. And we released the first variety that stood up like a wheat plant, and they loved it.
Yeah.
And so since then, they've been looking, I guess, to our stable for the next varieties. And you're only as good as your last release, so we've got to make sure the new ones coming out are better. And that sort of crept around to other parts of the world where they're looking for the same thing, I guess.
Yeah, it's great actually. It's sort of you work just across the road from FAR, and I don't think I fully understood the capability that was sitting right next door. It's amazing.
Well, it's really good to have FAR as neighbours now, because I know that we can maybe do a lot more stuff together. And I guess we've got a little bit right time, right place for some of our genetics, and we've just taken advantage of that where we can.
And that's the key thing, isn't it? To make for any success, there has to be a little bit of luck of just being in the right place at the right time, but then recognising the opportunity and being able to leverage it.
Yeah, I guess so. But the other thing is that we don't chase the really big commodity markets, and we do that typical New Zealand thing of looking for high value niche markets where we're not competing head on with the multinational companies. And we can get some traction in those sort of markets, and the big guys leave us alone, I guess.
So if you're back to being a grower, growing peas, what's your sort of guidance? What should growers be doing to be getting the best crop of peas?
I think that in New Zealand we tend to water a little too much sometimes. I think a little bit often is always the good key, and lateral irrigations, which are used internationally, always get a better result, because if you're using guns, you're dumping water on the crop, you're making it fall over. As soon as it falls over, it's not able to intercept radiation as efficiently. If you keep crops standing, it's intercepting radiation for as long as possible. If it falls over, you're creating microclimates for disease and other issues, sprouting if it gets wet. So try and keep it standing for as long as you can, and do that a lot by managing your water and also not putting nitrogen on the crop. Peas don't generally need nitrogen, added to them in New Zealand anyway.
And what are you aware of the fact that growers are probably putting on more nitrogen than is needed?
In some cases, yeah, you see some of our varieties that have really extended internodes and they grow too tall, and you find that the farmer has thought that they needed to add a wee bit more nitrogen, but generally just hold back from that. If you're doing a soil test and you find there's adequate nitrogen there, and again, look in this booklet and it'll give you a guide as to the range of nitrogen you're looking for, then leave it alone and it'll be fine. We've got really good rhizobial populations in New Zealand. If you've been growing white clover, you'll have rhizobia in your soil, so the peas will fix their own nitrogen.
Yeah. And what about at harvesting time? Any sort of tips for knowing best time to harvest, best way to get maximum sort of yield?
Yeah, I think a couple of mistakes at planting and harvesting is actually some farmers just drive too quickly, and when they're trying to establish a good population, particularly with a large marrowfat seed, and they're driving really fast, they literally can't. The machine just literally can't deliver enough seed to get the population going that fast. So slow down, drive slowly, and again, when you're harvesting, make sure your harvester is set correctly, test a bit, nudge into the crop a bit and try it. If you're getting a lot of cracked or damaged seed, adjust your settings. Generally peas like an open concave and not too fast with the drum speed, and harvest at about 14 to 16% moisture, and you'll get a much better result and much better seed quality coming out of that too.
Excellent. So the making peas pay, everything in there is still relevant, because how many years old is that?
Yeah, it's I'm not sure when it was done, but it was done with just about all of the seed companies in New Zealand contributed to that over a 3-year period with SSF support, and it's a great publication, and a lot of that is still very relevant. Some of the chemical names might have changed, and some of the variety names, but the basic principle of what drives crop growth, that hasn't changed and that won't change. It's radiation and thermal time and moisture availability. So you've just got to be aware of all those factors when you're growing a crop. Keep it intercepting radiation, keep the moisture, enough moisture to drive growth. Keep it free of disease, so you're keeping the leaf area there so it can actually intercept the radiation and do something with it.
Yeah, and make sure that we don't bring pea weevil back.
Exactly. That was a great one for the industry and
absolutely.
For the whole community to get rid of that.
You got to thank those North Island growers who were prepared to. They took one for the team.
They did absolutely. They did, and to keep it out of Canterbury is fantastic, because some of our export markets rely on the fact that we don't have pea weevil.
Yeah.
So good on, hats off to everybody involved. It was a real team effort to keep it out, and first in the world.
Absolutely. Yeah. So anything else that you would like to sort of let the growers know about this?
I think just that don't underestimate the value of peas in your cropping rotation. Don't just look at the price that you're getting for the grain. Think about what the benefit that they're having for your soil structure, for breaking your disease cycles, and improving your soil structure generally all around. It's a good option for a grower. And think about some of the emerging markets that are coming for peas. Some of the plant protein options that are starting to emerge. They're not quite in New Zealand yet, but peas are becoming a good option, and one that people want to eat.
Do you think, though, that we could make them pay in the plant protein space if it's already a global commodity market? Or are you talking about finding a unique point of difference around, a New Zealand pea cultivar? Yeah,
we've got to find our own space there, I think, because, in the big commodity markets, we can't compete there, and we don't really, I don't think we want to be competing there. But it's a matter of finding some added value in that space that we can call our own, and that might be flavour, it might be taste, it might be even blending our plant protein with our high quality lamb. and making a dual purpose food product which reduces the amount of meat that we're consuming but increases the amount of plant protein, and finding a way to blend those two very high quality products
That's
together.
right, to get some sort of unique flavour.
Very unique flavour.
I would love if we could make a ham and pea soup that tasted better than the ones that you can buy at the moment.
Yeah, I know. Or better than the chicken nuggets or the burger patties that they're making in the States at the moment with plant protein, which I personally don't really like the flavour that much. I think it's the first generation of those products and they've got a long way to go to make it really tasty.
But it comes back to what Ian Proudfoot from KPMG was saying, is that we actually have to not just follow what other people have done overseas. We have to create some point of unique difference. And, you know, we are really good at producing plant material and we're really good at producing, you know, sort of animal protein. Why are we not looking at hybrids?
Exactly. That's the whole point, is we've got the best lamb in the world. We can create good plant products, blend them together and make something unique. I'm sure the world would love it.
So are you sort of working in that space, or is that something
we're working a little bit with Washington State University Food Science Program are doing the testing of our genetics in the US. And what we're looking for there is a more horses for courses approach. If you look at the wheat industry, you have a biscuit wheat, you have a bread wheat, feed wheat, and they all have unique characteristics for the processes. At the moment in the States, yellow peas are just generic yellow peas, and they're not breaking them down into their functionality as much as they do in wheat. And we're trying to look for functionality within the genetics and then target that functionality to specific end products, whether it's a beverage or a burger or whatever. And they all require different things. If you want a burger, you don't want the fat leaking out, so you want fat holding capability. If you want a beverage, you want solubility, better solubility of the proteins.
I could spend all day talking to you about this, but we've run out of time. So thanks very much, Adrian. Lots of interesting stuff there.
Great.
And for our people who are watching the video, Make Peas Pay. That sounds like it's a really good little booklet for you to follow. So thank you very much, Adrian. Great.
Thanks, Alison.
And
Cheers.
thank you to the listeners. Have a great day on the farm.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.